How is everyone tonight? Hopefully you're doing well. I'm making some progress on the grading of exam 2, and hopefully that'll be done in the next couple days. So, but today I decided that I'm going to do some work with Marie, and it turns out I was thinking that we'd be able to download it and run it locally. The problem is it doesn't exist out there, or but it's behind a paywall or something like that. So I don't want to do that. But what I'm going to do, if you have access to those things, because if you bought the book, you do have access to it. So if you do have access, that's fine. Instead, what I'm going to do is I'm going to show you guys how to do this using the the marie.js.home. So what, I don't need the addition there. I'll go ahead and delete that. So I just want this. So let me go ahead and post that. I should be able to post it right into chat. Yeah, I can. So I'll post that right into the chat. https:// marie.js.org. So we can actually use this as to be able to download and upload. So we'll talk about how that works, and I'll look at a couple other examples. So what I want to do today is kind of walk you through a little bit on how to upload, and then we'll work on also outputting what we've got, and then I'll start going through some ways, some different strategies on doing things with this. Okay, so here in File, we've got New, Save, Upload, Download, right? So what we can do is we can grab a new one. Yes, just go New. Oh, actually, let's upload a file. So New just creates a new one, right? Wipes out whatever was there. All right, so I actually happen to have these 4 examples here. I don't even know completely what they do, but we're going to go ahead and open them up. So there was interesting. I have looked at this one. I haven't previewed the other ones. So let's look at this one. So it's real simple, right? To upload data path, help, examples. So there's definitely these examples here, but let's just try assembling this. Now notice all the other times we've used this, you would get your data here. So the thing is, though, they did this at the beginning of this file, so that adds 100 to all of the things. So we have to go down here. Wait, where is it? Oh, yeah, assemble. Okay, it's in here somewhere, I swear it has to be. Do the first step. Oh yeah, there it is. It was at 100. I was just missing it. Okay. So that's hex code, though, right? So okay. So here it is. And so, okay. And this actually explains it really well as it's stepping through this. So it says load the address of the first number to be added. So we go down here and we see there's this thing called address. That's 117. So it goes to 117, which would be 117, that one. And that's the address, which should get loaded in. And then the address is your next. Store this address is your next pointer. So it took that 117 and it put it right here in the accumulator. It also put it in the MBR, right? That's that buffer. then decrement number. So it goes out and gets number, which is here, dec 5, and it's going to decrement that. So it decremented it right here in the accumulator. And then it's going to store that in CRT, and the CRT is will be at 123. So nope, not 123. Oh, because this is decimal. Okay, so the A, B, C, D. Okay, D. That would be right here. It's currently 0, which makes some sense. So we step that. Did it not go there? What did I do wrong? Nothing. It stored it there. Stored the value in CRT, which should be right here. All right. So then we load the sum. So this is the command we're on, but this is the thing that we're pointing at. Oh, yeah, our MAR right there. So let's step back here a couple. Okay, so we see here CTR is that's after this next step, right? So because 1 is stored in E, it should be right here. No, oh, it's here. Okay. Oh, right. Okay, so that I made a mistake. This is A, B, C, D, E, F, and then this kicks over to the next one. So this is our 700 here. Yep, then that's right. And then jump is this one here, and it jumps to loop. And then I might be off by 1. I must be off by 1 because it didn't count the first one. Okay, so it's going to save this into the control, and control we know by our address is 116. So we can look, that's 116 is right here. So we took this. Let me go back to the beginning. Let's restart. Okay, so the first thing it did was it loaded the address, ADR. It's ADDR, and that's hex 117, and that gets loaded into the accumulator. Great, that's what we wanted. That's all that it does. It just loads it into the accumulator. It happens to be in the buffer because we retrieved it from memory. All right, so now when I take a step, it's going to store this in next. And if we look at where next is the very next one here. So that's here. So it's going to store that 117. Should store that 117 right there. Okay, perfect. Exactly what we were expecting. All right, so then we go back here, and now we load num. So we go down here, and we see where's num. Num is in 5. So let's take some micro steps here, because, num is here, so num is the very next one that has this in it. So when I do that micro step, I see the MAR changed to 102, which is this one. Because that's our next instruction. Is that right? All right, then it stores that value. I have it highlighted. Performed 1 microstep. Yep. All right, so now it stored that or not stored it, it's loaded it up. So it's loaded up into here. All right, so it moves to this, and then we need to watch. So then it changes the address to 113, which is this address right here. And then we take another micro step, and then that took in that value and brought it into the MBR. And then it put it into the accumulator. And now it's done. So I have to add a step. So then it's going to store the CTR. We can watch this as it goes. I kind of went over some of this before, but it's nice to review on some of this. It's been a while. So CTR is right here. So that's 23. And that will be in 104. No. We're loading in 104 because that's our new instruction. So we're going to... No, I'm sorry. It's not our new instruction. Our instruction is right here. Why is the MIR 4? Okay, so the MBR brings in this value here, which is the value in there. Okay. Yep. So then it stored it in the CTR position. Oops. Which was here. Which is here at 115. Oh yeah, right, because it's the 215 here. So, all right. So let me just toss all of this away, and I just wanted to go through doing a program. Okay. So how do I go about doing a program? So let's talk about a program. I'm going to give you some. So the first thing I want to do is I just want to say bring in 8 numbers. I'm going to bring in 8 numbers and just stick them into memory locations. Consecutive memory locations. So let's just make my memory locations. We'll start with doing that. And so the way to do this is, if we looked at the other ones, right, we just can put in, we can go like this, 1, comma, let me capitalize that. I'm going to put the caps lock on even. 1, comma, and then I can tab over, and then I'm going to call this, I'm going to say this is hex, and then 2, comma, tab over, hex, 0, 0, 0. What I want to do is, since I can copy here, I'm going to use my key. I'm going to do a copy, and then I go 3, comma, tab, paste, 4, comma, tab, paste. Well, I think for this, actually, I think let's just do 5 to start with. We can come back. So I just want to input these 5 values and stick them into place. Let me back up, actually. Well, I'm going to leave those there for now. Usually, all your variables are at the end. They wouldn't have to be, but generally, that's the best place to put them. If you end up putting them at the beginning, it gets tricky. You can put them at the beginning, but then you have to jump past them, which you certainly can do. Okay. Oh, actually, let me do that. Start. I don't know what the first command is going to be, but the first command here will be jump to the start. Okay, so now what I need to do is I need to input from the user, right? So let's look at our help. Let's see if the instruction sets. It is. That's very nice. All right, so IO, so input. Aha. Input a value. Okay, so then input. So then let's just store this in 1 to start with. And then halt. Let's just see what happens. Assemble it. We go up here and we look and see we've got some values in there. That's nice. So we step. The first thing it did is it reads the first jump. It jumps past all of our variables to the start. Then that's an input, which means I have to put in a value. I'll put in my favorite integer. And I'm going to call that decimal. And that's 2a, and that's actually correct. And so then I'm going to store that in 1. And lo and behold, look at that. It went right in there just like I expected it to. And then now we have a halt. Machine halted normally. Great. Okay, so let's come back in here. Now, so we could, if I wanted to, I could go ahead and read each of those 5 and just do an input, a store, input, store, input, store, input, store. That sounds like extra work, because I would have to, it's repeated code. So anytime I have repeated code, I don't want that. So let's try to make a loop here. Okay, so then here, we'll just jump right to the start of our loop. And so I'm going to call it loop. Let's make a new variable. I'm going to call this counter. That one will be hex. Because I have 5 of them, I'm going to go 0005. Okay. So now I get to my loop, and when my loop starts, what I'm going to do is I'm going to input the value here. So let's do an input on my loop. My start here will be to load counter. And we'll come back to work on how this all works. Okay, so then we can't just say store 1, can we? Well, we can say okay, I'm trying to think this through. So I want to store it in the place where 1 is, but I want it so that I can move forward and I can know which variable it is, right? Because this case it's just 1, but I don't want it to be 1. What I want it to be is to put it into a place that I don't know. How long it is, because eventually I'm going to extend this so that it can be as big as it wants to be. So I shouldn't have these things at the beginning. So I'm going to take those out. Okay. I also want to take, I don't want to take this one out, but I am going to cut it out of there and I'm going to put it down here. I'll come back and clean up some of this stuff. Okay. So let's do a load counter. Except for I want that to be in. So it lines up nice like that. Okay. So here in my start. All right. So what I'm going to look for here. Let's go back to my instruction set. Indirect addressing, don't care about that. There we go. My jump, skip condition. This is what I want. Okay. So I just loaded in that value. So what I want to do is this. If it's 0, if it's equal to 0, I want to skip the next command. You might ask, how does that work? All right, so, whoops. Let's go back here. Skip con. Skip con 400. So when that counter is 400, I'm going to skip the next command. And that command is to jump to the end. And make this my end. So then it will halt. It'll simply just halt. Okay, so in my start, oh, I don't need to start here anymore because that was because, so that jumps to the end. So this, now I'm just in my loop. Okay. In fact, though, at the beginning of my loop, I want to do the check, don't I? Okay, so input. Now, I've got this, and I want to store it All right, let's just, to begin with, the proof of concept, let's just sort into 1 here, and then load counter again. Subtract, is that how I do subtract? Yep. And then I'm going to subtract 1 from it. And then jump to loop. So this will go down through here, it'll do an import, it'll store it into 1 until this counter gets to 0, in which case it'll stop. And we'll have to deal with the rest of this in a minute. But, oh, I don't have a 1. Okay, well, that's good that it did that for me. All right, let's go ahead and do that. And so then now I can test it. So let's step. Okay, so it has already loaded the counter, and the counter is 5. Okay, and it loaded that into the accumulator here. Good. Now it's going to check to see if this is equal to 0. If it is, it's going to skip that. Oh, well, we should probably change that because we want to skip that all of the time as long as it's positive. Okay, so let's change that to 800. Well, let's go through this and see what happens here. It didn't skip the jump to the end, so it goes to the end and it halts. That's it. My program's done. So I made a mistake here, right? I need to skip over the jump only if it's positive. All right, so reassemble. Okay, we still have that 5 in there like we want it to be. And see, now this time, because that's a positive number in the accumulator, it's going to jump past the end. Or this next command, the jump to end. Okay, so now it does an input. There we go. 42. I'm going to leave it decimal this time. Okay, so now that's sitting in there because it converts it into hex. Okay, and then it's going to store that in 1, which it did. That's where 1 is, and we can tell that by the MAR, right? That gives us where the 1 is. Then we're going to subtract, or then we loaded the counter back up again, so we stuck that 5 back in there. We subtract 1 from it. Oh, I forgot to do something, didn't I? I subtracted 1 from it, that's all fine and good, but then I'm going to do a jump. Oh, okay. Well, that's problematic, isn't it? Because look what's going to happen. Stores that again, it loads it just fine, and then it subtracted 1 from it, but we don't see it because it's on to the next command already. Okay, so we don't have to do anything to stop. So let's now store this value in the counter. Okay, reassemble, start with the step. Okay, we've got our counter loaded up. Okay, we jumped right over that end because it's still above 0. We do the input. Then we go 42 again. Accept. Step. Okay, now we need to load the counter. So the counter gets loaded after we stored the 1 right where it needs to be. And then we subtract 1 from it. And our counter is right after our 1, which is here. Now, something weird happened there, didn't it? Oh, I know what happened. Let's try another approach. So let's do this. So 0, 0, 0. I bet you anything that's what's going on here. 42 goes in there. It stored that in 1 like I asked it to. It loads the counter just fine. It subtracts 1 from it. Huh. Why did it do that? Because, see, this is subtract t, right? So let's look here. Subtract t says subtracts the values in the accumulator at address x from AC. So what it does is it goes and gets the value at this address and subtracts it from there. Oh, that's not what I wanted at all, is it? No. Okay. So let's add 1 here. Hex 0001. And this time I can't have 1 as my storage. So I'm going to call this store. And I'm going to go back up here in the 1 space here, and I'm going to do that. And then here, and I'm going to do that. Okay, so I changed around so that I'm now going to store things in this store variable, which used to be called 1. And now I have a 1 variable so that I can subtract 1. Okay, let's reassemble that. Okay, skipping just like we're expecting it to. Put in our 42. Okay, now it's stored in a different spot, right, because it moved. That's okay. Subtract whatever is in the 1 position here. That worked exactly right, because now I've got my values correct. Okay, now I'm going to store that back into the counter, which is right here in C. Right, 00C. So it stored that 4 there correctly, and then I'm going to loop to the top, and then I'm going to input, and I'm going to take, say, 43. Okay, it stored it right in there. 43 is 2C. Good. Subtracts 1, saves it. That's a 3. Then it loops. 44. Down to 2. 45. Down to 1. Now, we do need to be a little bit careful here. I'll explain that in a second here. So now what should happen? Accumulator is 0. Because I put 800 there, it says it skips only if it's greater than 0, which isn't true anymore. Okay, good. So that means it won't skip, so it should jump to the end next. Aha, look at that. It jumps to the end and then halts. And that's over. Great. That's still not enough, though. Because what happened? Every number I entered, what happened? Where did it go? it went into one variable, one place, right? It went into that one place right here. Well, I don't like that. What I want to do is I'm going to move store. I'm going to cut it out of there and paste it in here. Okay, so I moved it down one. Does that affect the code at all? Yes, because things are going to be different here. The addresses of things will be different. But will it affect anything up here? No, because I'm not addressing anything. I'm addressing the labels. Okay, so here's a problem that I can see that maybe you might not see. At the end of this loop, I've stored counter. So counter is actually in my accumulator. But what happens if somebody else decides to use the same section of code and go to that loop? They might not have counter loaded. So I need to take and put my loop here. This won't affect my code at all. It just guarantees that I will load the counter because I'm assuming that it's loaded before I check the condition. Great. Now, this is what I'm going to do here. I'm going to go address. Can I do that? Yeah. Okay, so here's the thing. Now, what I want to do is I'm going to say this. I'm just going to say hex 0000, and the reason I put that, it's fine, it doesn't matter. What I need to do is I need to figure out where this is. So let's put make this that and reassemble here. So now I see it here. Okay. So this is address 00D. So I want this to be, oh, we could read, no, there's 4 of them in there. So this is going to be, oops, the address for the store variable. Oops, assemble. So now this is the address for that store variable here, right? Okay, good. All right, so what I can do now is instead of storing this in store, oh, let's go back here and look. Store. Okay, that's a direct context in that address. So I could just put that address in there, couldn't I? Okay, let's try that. So let's try just putting the address here, but I can't just put the address there. Well, I can, right? No, because that'll store it directly in the address. Well, how about if I just put like this? Is that going to work? Is that assemble? Assemble is just fine. Okay, so I put my 42 in there. Now see where it stuck it? Right there. Oh, because that's I gave it the wrong address. Oops. Reassemble. 42. It stored it there where it's supposed to. In that D spot. That's great. Okay. Now, what I want to do is I want to add 1 to this. So I want to add 1 to this address, but that doesn't make sense. Okay, so let me try this. Let me save this. Okay, let's go ahead and what I'm going to do is I'm going to do a download. And I'm going to say this one is just a, what am I going to call it? I'm just going to call it loop_example. And I'm going to save this as a text file, although you could save it as a MAS. Actually, I prefer everyone to save it as a text file now that I think about it. Okay, so now notice what happened here. Oh, you can actually see some of the things I was trying to deal with. So that is in my right here, and I can open that up actually. And it defaults open up in Notepad. Yuck, Notepad. I thought I had Notepad++ on here. And if we look, let's compare that to what I've got. It is indeed correct that some of the spaces are weird and wonky, but that's okay. It would load up just fine. So now it's in my download folder. I don't like it in my download folder. I'm going to move it. I'm going to put that on my desktop for now. I'm going to keep that handy because I might be using it still. Okay, so now let's go ahead and erase that's here. Yep, go ahead and do that. All right, now I want to upload that file. Okay, so let's go to my desktop. There it is. Boom, it came in just fine. So these were the two that were weird. So I'm just going to redo the double tab there, and hopefully that actually makes it better on the output. Okay, oh, then let's re-download. Yep, it's all perfectly fine. Open this, take this, drop it there, and it replaced it. Okay, good. All right, so. Oh, that's interesting. Okay. What we're going to do is I'm going to see about opening a okay. Look at this. See, this is subtract dec10. Subtract 1 from the loop control variable. That seems weird. Where's the loop? Well, jump, else. Well, let's try it. Let's do a symbol, and let's step and see what happens here. Subtract. So it loads X, and I have to scroll down here because I don't like that org thing. I could just get rid of it, but that's all right. Okay, so we'll leave it there for now. So this is that command. X is down here at 10C, or we see it out here at 10C. 110C, sorry. Should be right here. No, I'm sorry. Okay. 10C, that's where this is the location it's at. And 1 is the opcode, right? Okay, good. All right, so it's load. And so the next one here is subtract 10D. So 10D is this one. So it's going to take whatever was in there to begin with, which in this case was 12, and that's what that is. And it's going to subtract decimal 20 from it. And that gives us this FFFFF8, which is saved in 2's complement. It might not be a 2. No, it might be just 1's complement. It doesn't matter. It's a negative number. So now it says if AC is 0, which it wasn't, skip the next instruction. We're not going to skip that instruction. we're going to go ahead and, in this case, we're going to go to the else, which means we go down here and we load y. We subtract x from it, and then we store y. So now our new y, yeah, so this doesn't necessarily have a loop. This doesn't help us with our problem, though, does it? So what's our problem? Our problem is we need to be able to have a so then this is done, actually. This looks like it just terminated. So that's not a good one. That was this one here. Yep, so let's go to the next one. Traverses a string and outputs each character. The string is terminated with a null. Note, by changing the output window control setting to no line feeds, the text will print in a single line rather than in a column of characters. Okay, so let's hit the assemble, and we notice this program is very small in here. There's a bunch of stuff in here, but, okay, good. Okay, so we first start out, it says get ch. So it does a load I of CPR. Chapter, or character, sorry, character. It's supposed to be character? That doesn't make any sense. Okay, so if the character is null, we're done. And that is, null is the same as saying 0. Now, most of the time null means nothing, but in assembly language you have to assign it to a number. In this case we're going to call it 0. So if it's 0, then we're done, right? Which means we ran off the end of the end here. Okay, so then we can step. So we don't skip the jump to the output. So then we get to the output, we output the character. Where do we output the character? We outputted it right here. Oh, how about if we switch that to here? And there it goes. It goes H, capital H. Very good. And then we add 1 to the CHPTR, or PTR, character print, maybe. We add 1 to that, which in that is that hex 1, right? So if we look here, we're going to add 1 to that value. So it goes to 10C, good. And then we're going to store it back in our spot. And then we jump up to our top. And then we're going to load I, or loads the character found at that location. Okay, so what we can do is we can look at this same exact thing, and in fact what I'm going to do is, actually, I've got that here, and I wonder if I can open this up. No, okay, never mind. that didn't work out so good. All right, so let's actually do this. Let's go ahead and download this, but I'm going to call this not loop example, but ex4_3_3. I think that's what it was. I'm going to put that there. Go ahead and go back to this. Bring that over there, just so it's not on. Okay, so now I've got that in a text file, so I can refer to this as I'm working. That's handy. Okay. So now let's reload from the desktop my loop example that I'm working on. Okay, so what was the difference here? We did a load I, not on the counter, but on this address. Right, remember, that's what that did, right? So it loads that. Okay, well we're gonna do it a little differently. Well, let's look the difference. What's the difference between? Oh, there isn't a load I, is there? Oh, they're indirect addressing. Loads value from the indirect address in I. Gets the address value from the address pointer. Oh, that's exactly what I want. In fact, I don't need to do a load I for my address. I just need to save my address. Instead, though, I can do a store I on address. All right, let's try assembling that. Okay, we get our 42. Now, it's going to store that at the address's location. So that's 00, that's this one right here. That has a 10 in it currently. It's about to change to whatever is in here. Oh, that's a 42 in hex, I guess. Look at that. That's exactly what I wanted. Now, I load the counter, I subtract 1, I store the counter. Good. But I need to update the address, don't I? Okay. So let's update address. Load address. And this time I want to add 1 to it because I want to go to the next spot. So add 1. Then store address. I don't believe I've used this at all, but we'll see. All right, step. Okay, so we loaded our counter. Good. We jump to the end. There's our 42. Oh, that's in hexadecimal. That's okay. Then we step. It's now loaded. It's now stored that address. We're going to load our address. The address. What happened out here? Why did that? No, that's correct. So we load in our address. Oh, we added more code in. So this should not be start there. This should be 010. Oh, sorry, a 0 at the beginning of it. So start over. Step. Put in our 42. It stored it correctly here. Now I add 1 to the address, which is this, right? That's address it's loaded in. I'm going to add 1 to that, so that's going to go to an 11. It did. It's now going to store it right back in right there. Good. Then it loaded the counter. It loads the counter, and that's 5 still. It subtracts 1, so that's down to 4. It's not. Oh, then it's going to store that counter in counter, which is here. Look at that. Revert back to the original memory. Okay, well, that's fine. And then we jump back to the top again. We load our counter, which is still 4. We check to see if it's 0. It is, or sorry, if it's greater than 0. And it is, so we jump past the next one. Then we input here. Let's put in 43 and go ahead and hit accept. We loaded that we store that in that. Look now, look at that. It moved to the next spot, didn't it? Well, that's handy. Let's see how this works. 44. Put it in there nicely. 45. Look at that. It's going in good. 46. That was our 5th number. Now our counter's at 0. And we load it. So we don't skip the end. Now we go to the end and we halt. It's over. Okay, We never used this, did we? Let's get rid of it. But when we do that, we need to get to make this right. Right, because we can, oh no, we don't have to. We don't have to if we don't want to. We can just leave it the way it is, and it'll leave this empty, and it'll just jump down to the next line. That'll be fine. Oh, no, that's where it's supposed to be anyways. Okay, this is all good. All right, so we've got a few more minutes here. So what I'm going to do now is I'm going to change this up a bit so that my input will be the thing that decides if it should stop. So if my input, if I enter 0, let's stop it at 0. Okay. So we don't need a counter anymore, do we? Nope, we don't. So let's get rid of our counter. Any of our work with the counter. We're going to have to readdress when we're done, but that's okay. We'll come back and get that. Okay, and so then down here we can get rid of counter. We don't need it. Okay. So now the first thing I'm going to do is I probably shouldn't be doing that there. Let's just try a load. I'm gonna load one. I don't need to load one necessarily, but I don't want that first condition to be, I want to make sure that that first condition doesn't happen. Okay, so this jumps to the end if it's, okay, so then I input. Now, this is where it gets tricky. Because if the input is 0, so what happens right here, right? When this is 0, what should I do? Now I should jump to the end. So I can take this condition out. And then I can put the skip condition here, and I can have it 800 like it was before. Now I don't need this at the beginning because the input is there. And then I can put the loop to begin with here. Oops. Okay, so I'm going to input, and then I'm going to check that input, see if it's not 0, and then I'm going to jump to the end. And if I did, I'm going to jump to the end. Okay, so then I'll store it in the address, whatever input it. Then I'll load the address, add 1 to it, store the address, and then I'll jump back to the top again. Okay, it's still stuck at here. So now we're not using these right here, but we don't really care about that, at least at this point. We could readjust it later when we come back, but at least it's past the end of our code. All right, so it loads the address in, that 10. I'm going to go ahead and add 1 to it. So now it's 11 in the accumulator, and then we're going to store that back in. Then we jump up here, and then we're going to keep going. So let me just try running it. All right, I'm sick and tired of it. I'm just going to put a 0 in there. Okay, so look what happened. Put the 42, the 43, the 44, the 45. And it just kept moving along doing that. That's wonderful. Okay, now I want to add a couple other things. Okay, so I don't want this to be, so now what I want to do is I want to go through all of these and find the largest number. Oof, that's a tricky one, isn't it? And then I'll output that biggest number. And and I leave that, I think, I don't think I can accomplish that in the next 25 minutes, but you know what? I can at least start working on it. Okay, so let me save what I've got. Okay, I don't want this. So I'm going to call this my loop example. That's what I named it. I download that. Put that here and replace it. Oh, this is not going to like that. Oh, that was a different one. Okay, there it is. All right, good. And it even formats nicely. It looks good. Okay, so no, what I need to do is I need to create another subroutine, don't I? And I need to create it before the variables. Notice here why it's useful to have the variables at the end. Remember before I had them at the beginning. The problem with having it at the beginning is I can't do this thing with, have an infinite number, because, right, I could just keep typing in numbers and it would keep storing them. It doesn't care. And it would fill up the memory. But I'd be here all night, right? So I don't want to do that. Okay, so here, instead of jumping to the end, this is where style matters. What I'm going to do is I'm going to add another thing here, and I'm going to, I'm going to change this to say exit. And then up here, I'm going to put exit. All right, now, something weird happened here. There we go. All right, so now what I'm going to do is I'm going to add in here what happens when we do end. Oh, no, this isn't exit. This should still be end, because that says go to my subroutine that's going to read all the numbers in, and I'm going to call this end loop. Okay, good. Okay, so in the end loop, I'm going to get another address here, and I'm going to call it end A, and that's going to be the same as the first one. So those are going to match. And so what I'm going to do here is I'm going to do a load I based on end address. Let me just call this end, not end loop. The reason why I do that is because I need to handle that first character differently than the rest. All right, let's just test this. See if this works. Actually, I'm just going to click, 42. So I'm just going to click run here. So 43, 44. And now I can put a 0 because I'm testing out to see if it'll jump back to my end properly. Oh, it did. Okay. So, but what I want to do here is output. Just output. So 42, or 32, 33, 0. Look what happened on the output. 2. Why did it do 2? Oh, that's Unicode. Change that to hex. 32. Oh, look at that. Okay, so it output the first value, whatever was in the accumulator. That's good. But what I need to do is I need to go through and test to see what's the highest. Okay, so let's add a place to store highest. Let's do that. High. In this case, I'm going to say high is just that. So here, what I'm going to do is I'm going to do a store high. So, because the first one is always the highest. No problem. All right, let's just see if this works. So 42, 43, 44, 0. Okay, what happened? Oh, it stored it in high, didn't it? It stored that 42 right there where I expected it to be. Good. And 13 would be the very next spot here, right? 0, 1, 3 is the next spot that's open. That's why that's a 3. Okay, so we're going to store that in the high. But now what we need to do is we need to load end A directly this time. And I need to add 1 to it. And then store end A. So first, before I actually jump to all this, I'm going to leave that stuff there, but what I'm going to do is, first off, I'm going to add an extra 1 to these. So these are now 1 row down. It gives me a little bit more space. So let's just look here. 42. Well, let's just do it simpler. 1, 2, 3, 4, 5, 0. Okay. Now, remember in assembly, it's just going to go straight down the line. Oh, you know what? In my effort of doing things, I actually let somebody closed my stream. Okay. That's still there. All right, good. All right, so here, the thing is I'm not doing anything with these, right? I did store it in high, so I stored 1 in high, which is here. No, I'm sorry, here. But, oh no, that's the 1. This is high, right here, yep. So I stored the 1 there. And then I fixed my end A. So this is end, and this is end A. So it started at 20, but I added 1 to it, so it's 21 now. Okay, so let me try this. Instead of storing this, I'm going to come back to that. What I'm going to do is I'm just going to do an output. Okay, 10, 11, 12, 13, 14, 0. And look at that. It output, instead of storing it, right, it output that number. Okay, so then let's go here, and instead of, because it goes in line, the next thing is exit. And it doesn't say, hey, there's a label here. It just says, I'm just going to keep going the next command. So it does the next command, which in this case is halt. So that's why it ends. So then I'm going to say, go to end. Okay. Assemble that. Let's run this again. 10, 11, 12, 13, 14, 15, 0. Whoa! What's going on here? All right, let's go ahead and pause that. All right, it did everything nicely till it gets to here, and then it just keeps on going forever. Oh, wait a second. We don't want to do that, do we? No. Okay, so when this address gets equal to this address, then we want to stop, don't we? Aha, okay. So what we're going to do is we've just stored end A, so that's going to be in our accumulator. So then let's subtract, what's the name of our other one? Oh, address. And then I can do a skip on the condition that it's not 0. Ooh. No. I subtracted how far I went with the other one. So as long as it's a positive number, still I'm good. Okay, so what's the positive number one? That's 800, just like I did before. So let's see if that will do it for us. 11, 12, 13, 14, 15, 0. Look at that! Okay, now, the only thing is it printed one too many, didn't it? So why did it do that? Oh, we could do some funny things here. All right, so I'm not exactly sure what happened there. Okay, oh, you know, it looked like I could put breakpoints in here, so I think I can do that. So let's see if that works. Okay, let's do a run. The reason why is because when I put the 0 in, it actually saved it, didn't it? By the way, see I put that in there? That's a breakpoint. That means it will stop when it gets there. And now I can go back to stepping one at a time. But what I realized is here, no, it shouldn't have. The address is one too high. Okay. Oh, I didn't clear this screen. So it skipped, it's printed out 14. Or there's the 15. So then, oh yes, so it's going to look at the 2A, which is the one right here, okay? So that's looking at this because that's what's in our MAR. Aha. Okay, well, there's an offset of 1. So we can subtract 1, right? Because we've got that variable 1. We can just go ahead and do that. Ooh. What happened there? Subtracts the value in the AC at address X into AC. Yep. All right, let's see what happens here. Okay, so we store that. We upload. Oh, we take 21, which is what we are at now. Oh, we got a negative number. and then we're going to subtract 1 more from it. So that's all fine and good. Okay. We might need to add 1, because then we jump back up here and we output that. This time we're now it should do the 15. Good. Now it output the 0, 0. Okay. But here, see, it's F, 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 F. So let's not subtract a 0. Let's get rid of this and make it 400. So when it gets to 0, it will stop. 11, 12, 13, 14, 15, 0. Oh, it's stopping at my breakpoint. Okay. There we go. Voila. So now I've been able to input it and then print it out 2 different loops. Okay? It's nice to have that other loop counter. All right. So this is good. Now, the only thing is, I want to, and I'm not going to be able to do it. I guarantee I will not be able to do it. But I read each one of those in. So what I can do is I'm going to now come back next time, and we're going to work on this and try to finish it up. Take what I've got. What I'm going to do is, instead of putting out notes for this class, what I'm going to do is I'm going to put out what I've just written here. And I'll call it the loop example, I guess. And then what we can do is, or what you can do if you like, you can go ahead and play around with what I've done so far. All you need to do, right, is to go in here and do an upload. I'm going to currently download what I've got. Let me, sure, yeah, loop example here, perfect. And then go here and then drag that. That's what happened. Drag that under here. So normally I use Notepad++ for all my work, but my work is, oh, it's interesting. My work is not done on my laptop, so I don't have Notepad++. So I'll try to get Notepad++. I think it just looks nicer, and there's a lot more code and tools and stuff there that are useful. All right, yeah. Let me post that now before I leave. Communicational materials, content. Oh, I'm behind. I'm behind by some lectures, right? So it looks like I need to oh, I need to do some work here. Because I don't have 27, a PDF for 27. At least it doesn't look like it. 27 or 28. All right, well, I'll have to fix that. All right, I'll get this uploaded. It'll be uploaded in the next few minutes. And then hopefully this is helpful for the Marie stuff. And then I'm going to have, hopefully I'll have an assignment ready for you guys to do, to kind of get your feet wet, at least a little bit here in assembly. And then we'll do another one after Thanksgiving. So I think the program is intended to be due over Thanksgiving, but we're going to do Marie again on Thursday, so tomorrow, and then next week on Thursday I'll do Marie after I cover Chapter 10, which is the embedded system stuff on Monday and Wednesday. And then that should give you guys a good leg up on being able to work on a project. So, and that project will involve a loop, so make sure you understand how that works. Okay. Yeah, I think that's all I've got. So I will talk to you guys in a couple days, or not in a couple days. I'll talk to you tomorrow, and we'll try to finish this program and maybe actually try to do something else. So we'll look at some interesting things to do. All right, thank you. I will talk to you guys in a day. Bye bye. I will talk to you guys in a day. Bye bye.